Morning, students. So today we are going to learn further in continuation of AC circuits. Let us introduce myself. My name is Dr. C.H. Yadaya, Senior Lecturer in Electrical and Electronics Engineering at Government Polytechnic, Husnabad. Today topic regarding to third semester AC circuits 18 EE 302C. The first chapter, Kirchhoff laws and star delta transformations. Let us see. So what we have seen in previous classes. In the last period, we have discussed one electrical circuit introduction, the components of electrical circuits and active elements, passive elements, active circuits and passive circuits, and node and mesh. Now, in this class, further we are going to learn same electrical circuits and further other terminologies. Instead of node, what is the branch, what is the loop, what is the mesh, and what are the different terminology across in our electrical circuits. Let us see. Our main objects on completion of this topic, you would be able to know what do you mean by junction and branch, loop, and main definition of Kirchhoff Current Law and application of Kirchhoff Law. Okay, let us see one by one. Now, what do you mean the junction? So, last class we have seen our electrical network consists of different electrical circuits. The electrical circuits consist of number of passive circuits and active circuits. In network may be consist of number of passive circuits and active circuits. What do you mean with the passive circuit? The circuit which has only passive elements. What are the passive elements? As we know that passive elements are resistance, inductance and capacitance. That means resistor, inductor, capacitors or passive elements generally used in our electrical engineering system. These are the three dominating elements used in our electrical networks. Now, what do you mean by the active networks? The active networks is nothing but the consisting of positive elements and the active elements and passive elements. Now, passive elements we know that RLC. Now, what are the active elements? The active elements are batteries, energy source elements, whether it's a current source or voltage source. That means it may be battery, it may be generator. So, combination of this battery and loads are RLC. Sources are the sources are voltage source and current sources. If there is a sources and loads are consist and connected in a systematic way, that is known as the electrical circuit intended for a specific purpose. Now, so in that electrical circuits, the electrical circuit consists of active elements and passive elements. There is a few terminologies across these circuits. We should know, as because we are the electrical students, we should know this basic terminology. Now, in this case, first one is a junction or node. So, what do you mean by this one? The point where two or more electric circuit elements are meet together is called junction or node. So, the definition, node. For example, this is a one node. It's a junction point. Just like in a traffic signal, where in road, if you are observing road, there is a traffic junction. So the vehicles coming from the left side, coming the right side, and coming the another sides at junction, they will stop based on the traffic signals. That is now the junction. Similarly, here is also junction, our electrical junction, where different elements, here is connected to the one resistor, here is connected to the one inductor, here is connected to the one battery, and at common point we can say this is the node or junction. So don't bother about the confusion, we will see one by one later with the help of the figures. Okay, so what is the definition? The point where two or more electric elements. Now you can see here one element, for example this is a one element, red color. This is coming one side, the vehicle is coming one side, the left side, and another vehicle is coming from bottom. It's a junction now. Now you can see is another vehicle is coming also this direction, and the common point is connected to the node, and so all are coming towards the node, and here one of the vehicle is going away from the node. So here some of the coming towards, some are coming away. So this common point is blue color is the node. Now you can see it's the point where two or more electric elements. Here is the red color and the violet color, and this is the which color? Maroon color. These are the we can say as the some elements. At the same time green also some element. Now the four elements are connected, combined at junction point. At one point, that point is known as the node or junction. Now you can see here one example, junction. What is the junction? Here you can see it, some vehicles are coming this direction. So some vehicles are coming this direction, some vehicles are coming this direction, some vehicles are coming this direction, some vehicles are coming this direction. Now this yellow color is known as the junction. So that means here the common point. So some vehicles may be this direction, some vehicles may be this direction, some vehicles may be this direction. So this common point is known as a junction. Similarly, in our electrical engineering also there is a one junction or node where instead of here connecting the vehicles, we are connecting the some resistance, some inductance, and we are connecting the some capacitance and some also inductance. All are connected one place, the common place. This is known as the junction. I think you have cleared it. Now let us see. Now junction or node in our electrical circuit. Now here is a voltage is connected, a resistor is connected, capacitor is connected, inductor is connected. So all voltage terminals, all voltage one of the terminal, resistor one terminal, capacitor one terminal, and inductor one terminal is connected to the at one point 1, and remaining terminals, the end of this one is a head and tail. For all heads are connected at a junction. You can see here. So this is connected, this terminal is connected here, this terminal is connected here, this terminal is connected here, this terminal is connected. So there is no, here is a common point, and remaining second terminal is connected here, this connected, this connected, this connected. Now this common point, and now this common point is known as the 1, this common point is the 2. So 1 and 2 are known as the nodes, nothing but in electrical engineering also. So this circuit can be written so in simple way, see here. So there are the two nodes 1 and 2. Now if you are seeing this one, what is happened? The all terminals connected 1 and 2. Here there are the two nodes. One node is the 1 and node is the 2. So we can say two junctions, one junction 1, junction 2. All terminals are connected. Okay. So this is a junction of node, common point, nothing but common point. Now what would be the branch? Let us see. Node is known. Now so what are the nodes in this circuit? The node 1, node 2, node 3, node 4, node 5, node 6. Red color dots are the nodes. because a node 1 is connected to the voltage source and resistors 1 terminal, and node 2 is connected resistor 1, resistor 2 and resistor 3 1 terminals, and resistor 3 also connected resistor 2 and resistor 4. Similarly, there is a 5 nodes in this one. Okay, so not 5 nodes, so 1 node, 2 node, 3 node, 4 node, 5 and 6 are the common. So only 5 nodes present in the circuit. So in addition to the nodes, now let us see the branch. Branch is the some part between the two nodes. Here a part of network is connected in between two junctions is called the branch. A part of network. So the complex, because our electrical networks are the complex circuits. It's a zigzag circuits. So in that one, some part we are taken out. In that one, so we know that a part of network is connected in between two junctions. Here junction 1, junction 2, node 1, node 2, we connected the R1. So this R1 is known as the branch in between the 1 and 2. And R2 is a branch in between the second node and third node. The branch, you can see the node 2 and node 5, there is a one R3 is connected. This is also one branch. So you can see here, this is the one branch in between the first node and second node, and this is another branch, it connected the second node and third node, and this is the another branch, this is another branch, this is another branch, and this is another branch. So these are the definition and meaning. A part of network is connected in between two junctions is called the branch. There are the 6 branches you can observe, 1, 2, 3, 4, 5, 6 branches. Element, which are the, whether you are connected with the active elements or passive elements connected between the two junctions, that element where you are connected, that is nothing but one branch. Okay. Now, so a part of the network is connected in between two junctions is called the branch. Now already we seen. Okay. Now loop, coming to the another term is a loop. A loop is a closed conducting path in a circuit. A loop is a closed conducting path in a circuit, because there is a circuit, in that one is a whatever the current is leaving from the terminal, and same current is entering it in case of the battery. So that is a one loop. Closed path is nothing but loop. So you can see in the figure. Now what happened here? Whatever the current, so here you can see the current is coming from positive terminal. For example, assume the current is passing through this one and entering here. So this then node 1, you can see this one, and next you can see here, this is also same, the current circuit is coming in the loop. Here is another loop. Loop is the closed one. Here is the closed one. Here is the closed one. Okay. So these are the loops. Now what is the definition? A loop is a closed conducting path in a circuit. It is a part of the circuit. Now this is a one loop, and this is a, so terminal 1. What is this one? Loop 1, 1, 2, 1, 2 and 5, 6 and 1. This is a one loop. And another, you can see second loop. Second loop also, what is that one? So 2, so 2, 3, next this one, this one, this one, that is this is another loop. Now further, so you can see the another loop also. Now what is happened here? So if from this one to current is going, this coming and this coming and this coming, this is a loop. That means starting ending should be closed. This is known as a loop. So this is the first loop, this is the second loop individually, this is the first loop, and this is totally, this is the loop. So this is the meaning of the loop. A loop is a closed conducting path in a given circuit. Okay, there are the, here is a 3 circuits, 3 loops, L1, L2, L3. Okay, now coming to the another is termed as a mesh. So it is a loop that contains no other loops in it. That means individual loops only, known as a mesh. Previous cases loop 1, loop 2 and loop 3. Whereas a loop 1 individual, loop 2 is a individual, but whereas a loop 3 is a combined with the two loops. So here there is no combination of the loops. Individual loops is known as a mesh. Let us see. Now same circuit. Now you can see this is a one loop, mesh or loop. This is a 1 2 5, 1 2 5 6 1 and mesh 1. This is the another mesh loop equal individual loop, nothing but mesh 1, mesh 2. Now there is no common thing. These are the two meshes only. So these are the two meshes in the circuit. I think don't confuse it. Loops may be closed one. You may be going this direction, you may be going this direction, you may be going this direction. But whereas the meshes, there is no common area. So the loop 1 individual, loop 2 individual. Okay, that is the meshes. These are the few terminologies you are going to learn. One is the first is the what is the node, what is the loop, what is the mesh, what is the branch. I think these are small things, but you should remember because electric circuits gives very difficult problems. Okay, now Kirchhoff's current law. Let us, after knowing some parameters, terminology in network circuits, let us see now our basic principle is the Kirchhoff current law. What is need of Kirchhoff current law? As we know that in any circuit, if we know that voltage and current, then we can know what is the parameter of resistance. As per Ohm's law, at a constant temperature, the current in a closed loop is directly proportional to the applied voltage. So as per the Ohm's law, we know that. So here, what is happening? The formula we know that. So here V is equal to I into R. So three elements. This is a one active element, and this is the active element. This is a passive. This is the active element, and this is a passive element. Parameter, nothing but. So if you know the voltage, if you know the current, we are going to find that resistance R is equal to V by R. If you know the I, if you know the resistance, we can easily find the V is equal to I into R. So based on these three parameters, two unknowns, one unknown, we can easily calculate by using this any circuit parameters. But it can be applied for the only linear loads where so V is directly proportional to the I. May not be V directly proportional I square cannot be used this Ohm's law. So Ohm's law can be used for only linear circuits. Obey the Ohm's law. Now see, even it is a obey the Ohm's law linear circuits, sometimes unable to calculate the problems. Then so we cannot use this Ohm's law, simply Ohm's law. The advancement of Ohm's law is nothing but so Kirchhoff law. Kirchhoff is a scientist. He found the easy method to analysis the complex circuits with the help of his invention. Those are known as the Kirchhoff's laws. He has invented two laws. One is the current law and voltage law. Kirchhoff current law, KCL, Kirchhoff voltage law. Kirchhoff current law can be used at junctions, nodes, as we discussed previously. Whereas Kirchhoff voltage law or mesh law can be used in meshes, in closed loops. So these two laws are used to calculate unknown values, the currents, voltages, resistance in a complex circuits, somewhat better than the Ohm's law. So now let us see, this is a very easy law and everyone easily enjoying by using this KCL laws. Now let us see the first law, KCL, Kirchhoff's current law. What do you mean by the Kirchhoff current law? Now in any electrical network, the algebraic sum of currents meeting at a node is equal to 0. As we previously have seen, at a junction, at traffic signals, the all vehicles coming the 4 directions may not be stay at junction further time. It will stay up to red signal. After green signal, there is no vehicle present at that condition. Simply coming and going, there is no storage at that position. Similarly, here also same thing. So, algebraic sum of the currents entering into the node is equal to algebraic sum of the current leaving from that node. We can say another way. In an electrical network, at any junction, the sum of incoming currents is equal to sum of outgoing currents. Let us see, here is one example. The currents entering nodes equal. Here, what is the currents entering? I1 is entering, and I2 is entering, and I3 is entering. Sum of the current entering is equal I1 plus I2 plus I3. 3 vehicles are entering at the junction. Now, at the same time, from that junction, so I4 and I5 is leaving from that junctions. The currents are outs, currents are ins. So, now what are the currents? I1, I2, I3 is equal I5, I4. That is equal sum of the currents entering is equal to sum of the current leaving. Now, here we sign is taken a convention that the entering currents, that is the money coming to our pocket. The outs are different energy, different sources. So, from salary, from some rents, from the lands, we are going to get the every month some amount of the rupees, where some amount of the rupees coming to our pocket, we taken as a, it is a credit. Once, what are the amounts we are giving to the house rent and milk and grocery, that's we are giving the amount from our pocket, that is a minus values. Similarly, here is our pocket is our shed pocket is a junction, and coming amounts from the different sources are taken as a positive, and amount taken out from the our pocket to other people, that is taken as a debit, minus values. Similarly, here also the currents entering the node we taken as a positive, and currents leaving that nodes is equal to negative. So, based on this one, what is the formula? Algebraic sum of these currents entering at node equal to 0. Now, we taken as a I1 plus I2 plus I3 is a positive, and whereas I4 and I5 is a leaving, we taken as a minus. Now, that is equal to the 0. By simplification, so we are going to get I1 plus I2 plus I3 is equal to the I4 plus I5. This is a simple Kirchhoff's current law. If have any doubts, further we can do analysis. Let us see. Explanation. So, consider the following example for explanation of Kirchhoff's current law. So, you can see our electrical circuit is a complex network. Similar to this junction, you can see the road junctions are track, railway tracks. So, this is the road junctions. You can see how many vehicles are changing at this junction. And similar, our electrical circuits also same thing. So, this complex circuits easily calculated by just as following the some tips. Now, here junction is the A. So, you can see our junction is the here A. Here we connected different elements. So, here elements are connected. This is the one element where this is connected element. We are connected this element, and this element, and all are connected the common point here. Now, you can see also the direction of the current in these circuits are different. Now, what is this one? The here is current is going this direction. Here is current is coming toward the junction. It is coming away from this one. It is coming inside. It coming inside, and you can see arrow marks. So, this algebraic sum of the current at node at the instant equal always 0. Now, that means, so simply, so here vehicles you can see some of the vehicles coming to the, this is you can see the node or junction. Now, junction, some of the vehicles coming this direction, some of the vehicles this direction. How many vehicles are staying in the junction? 0. Simple coming and going. There is no storage at that junction. So that is the examples of Kirchhoff current law. Okay, so no vehicles are staying at that for 1 hour, 2 hours, simply coming and going. So what are the vehicles enter the junction? If you are observing in a CC camera, same vehicles will leaving nodes. So where the junction is the our CC camera. CC camera at traffic signals, it will observe this. Suppose 500 vehicles is coming here and 500 vehicles leave that position for a particular time. That is the KCL. Okay. Now the Kirchhoff's current law further. So from that circuit, a junction A, the sum of the current entering is equal to the sum of the current going. That is the sum of incoming currents is equal to the sum of outgoing currents. Now here we can see simply further. So here is a junction. So here what is the junction? Here this is the junction and vehicles are coming this direction and the vehicle at this direction and the vehicles are this directions. Now the sum of incoming currents is equal to sum of outgoing currents. Now here vehicles you can see here. So what is happened? So red color it is coming this direction and this vehicle also coming this direction and this vehicle is this direction coming this direction. So this is junction. So in junction, so we are going to, what are the vehicles presents? 0. So this vehicle will come and will go this direction, and here incoming current. So this 1, 2, 3 are coming and 4th is leaving. So that is the same thing analysis in our circuit also. Now I think you have some idea. Now sign convention. What is the sign convention? So a sign convention here is the so simple our money pocket. Notice our money purse. So in that one, so amount is, if you are coming towards our pocket, it is a positive, and leaving from our pocket is a negative. Now consider the current which flows towards the junction or assigned as a positive, and you are taking the positive, and we take the positive. Now current flowing away from the junction or assigned as a negative. The amount is going from our packet. So some was uneasy. Then we take in the negative. Then you can see the negative. So these conventions you should remember while doing the problems, simple problems. Okay. Now application of KCL, Kirchhoff Current Law. From the KCL statement, the algebraic sum of currents at a junction A is equal to, so as we see in circuit we know that at junction A from the circuit, so I1 is, what is happening? So I1 is leaving from the A. You can see here I1 is leaving, so we taken as a negative, and I2 is coming, we taken as a positive. It's coming this direction junction, and this is a, what is this one? And next this is also, it take, so this is also coming this direction, and this is also coming this direction, and this is also leaving. I think this is a leaving this direction. Leaving is a negative, it is taking this a positive, this is a positive, okay, this is a negative. So based on this one, so we are going to calculate minus I1 plus I2 minus I3 plus I4 plus I5 equal to 0. Algebraic sum of current at a meeting junction is equal to 0. Simple algebraic sum of. So then, so by writing this equation, we are going to get that, so incoming currents are I2, I4, I5, and outgoing currents are I1 and I3. This is the simple applications. Okay, so I think you have very perfect in this thing. Now you do the one problem. Let us do. For example, you taken the, if the given currents are I1 equal to I2 is equal to 3 amperes, then I3 is equal to 2 amperes, I4 is equal to 5 amperes. Then what is the current I5 current in the circuit? Okay, let us do it. So here same equations. So what are the currents? I1, I2 is equal to some values are given 3 amperes, and I3 is a 2 amperes, I4 is a 5 amperes. Now we have the of 5 elements here, 4 elements is given. We have the one equation. The algebraic sum of the current entering at the node equal to 0. Simply you write the formula and substitute the values. We are going to get the answers. Okay, let us try it. Okay, you can do it. Same, you can check it. So, same formula you are going to apply it here, and current entering towards the node equal to take as a positive, and current leaving from that node taken as a negative. Based on this one, you apply the formula. Now, write the formula and substitute the values. So, what is the I2 is equal 3 amperes, and I4 is equal 5 amperes, and I5 we don't know, keep it as, and is equal to I1 is 3 amperes and I3 is equal to 2 amperes. By simple multiplication, so we are going to get, so 5 get cancelled, so I5 is equal to, we are going to get that, so I5 is equal minus 3 amperes. That means the current in this case, the current which is I5 we referred as a coming towards a node is not coming this node, it is a current has to leaving from that node. So, what is the value? I5 is equal minus 5 amperes. This is a one example. Okay, simple formula. Now, so this is a one problem. So you do the remaining all calculations, simple problems you do it. Okay, so this is a one thing you have to remember. So what are the summary what we have discussed in this class? So we discussed some terminology regarding to the circuits. A junction is a point at which more than one ends of the elements are connected and division of current takes place at that junction. You have to remember. At the same time, all elements are connected, common point is a junction, and at the same time you can observe at that condition the distribution of currents takes place. So at that point is known as the junction. A part of the network or circuit is connected in between two junctions is known as a branch. A loop is a closed conducting path in a circuit in which no element or node encountered more than once. Only one time you have to reach. A mesh is a loop that contains no other loops in it. Individual loops is nothing but mesh. Okay. And coming to this one, in any electrical network, the algebraic sum of currents meeting at a point or junction is equal to 0, KCL. That is the algebraic sum of I, sigma I is equal 0. In any electrical network, the sum of incoming current at a junction is equal to sum of current, sum of the outgoing current. This is another way of expression of KCL. Kirchhoff's current law is only applicable in electrical networks where junction takes place, where the junction is present. Kirchhoff current law is only applicable in a closed mesh or path of the electrical networks. Okay, so these are the things already we observed and known in this class. Okay, thank you very much for listening this class. If you have any doubts, we will discuss later. Okay, then so please go through this class and make it notes. If you having any doubts, we will clarify next class.